Welcome to the chemistry topic General Principles and Process of Isolation of Elements. A few elements like carbon, sulfur, gold, and noble gases occur in free state, while others in combined forms in the Earth's crust. The extraction and isolation of an element from its combined form involves various principles of chemistry. A particular element may occur in a variety of compounds. The process of metallurgy and isolation should be such that it is chemically feasible and commercially viable. Still, some general principles are common to all the extraction process of metals. For obtaining a particular metal, first we look for minerals which are naturally occurring chemical substances in the Earth's crust obtainable by mining. Out of many minerals in which a metal may be found, only a few are viable to be used as sources of that metal. Such minerals are known as ores. Let us see the definitions of minerals, ores, gangue, metallurgy. The naturally occurring chemical substances in the Earth's crust which are obtained by mining are known as minerals. Metals may or may not be extracted profitably from them. The rocky material which contains sufficient quantity of mineral so that the metal can be extracted profitably or economically are known as ores. The earthy or undesirable material present in the ore are known as gangue. The entire scientific and technological process used for isolation of the metal from its ore is known as metallurgy. From the ore, after removing that bits of sand and rocks, we are getting the metal compound. From the metal compound, we have to extract metal by chemically separating the other elements. These are some principal ores of important metals. For example, bauxite and kaolinite are the ores of aluminium. We are extracting aluminium from bauxite. Here, hematite, magnetite, siderite, and iron pyrites are the ores of iron, whereas from hematite ore only we are extracting iron profitably and conveniently. Copper pyrites, malachites, cuprite, and copper clans are the ores of copper, whereas we are extracting copper from copper pyrites. Zincblende, calamine, and zincite are the ores of zinc, whereas zinc is extracted from zincblende. Now, which are the different steps of metallurgy? Mainly, there are four steps for metallurgy. First step is concentration of the ore. Second step, conversion of concentrated ore to oxide. Third step, reduction of oxide to the metal. And fourth step, refining of the metal. Now, what is meant by concentration of the ores? Removal of the unwanted material like sand, clay, etc. from the ore is known as concentration, dressing, or benefaction. It involves several steps, and selection of these steps depends on the differences in physical properties of the compound of the metal present and that of the gangue. The type of the metal, the available facilities, and the environmental factors are also taken into consideration. First method for ore concentration is hydraulic washing, which is also called as gravity separation. It is usually applicable to oxide ores in which the ore is heavier than impurity. It is based on the differences in densities of ore and gangue particle. Ore is washed with a stream of water under pressure so that lighter impurities are washed away, whereas heavier ore particles are left behind. Next method is magnetic separation. This is based on differences in magnetic properties of ore components. If either the ore or the gangue is capable of being attracted by a magnetic field, then such separations are carried out. For example, in the case of iron ores, the ground ore is carried on a conveyor belt which passes over a magnetic roller. The magnetic component will fall closer to the magnetic roller and non-magnetic component falls away from it, by which the components can be separated. This is the diagram of magnetic separation where the finely ground ore is poured over the conveyor belts, out of which one is a magnetic roller, and the magnetic particles are falling closer to the magnetic roller and non-magnetic particles are falling far off. Next method is froth flotation method. This method has been in use for removing gangue from sulfide ores. In this process, a suspension of the powdered ore is made with water. To it, collectors and froth stabilizers are added. Collectors, for example, pine oil, fatty acid, xanthates, etc., enhance non-wettability of mineral particle, and froth stabilizers, example, cresols, aniline, etc., stabilizes the froth. The mineral particle become wet by oil while the gangue particle by water. A rotating paddle agitates the mixture and draws air in it. As a result, froth is formed which carries the mineral particle. The froth is light and it is skimmed off. It is then tried for recovery of the ore particle. This is the diagram of froth flotation method where you can see a mixture of powdered ore mixed with water and pine oil is taken in the tank in which a strong stream of air is passed for agitating the mixture. So as and when the froth is formed, it carries the lighter sulfide ores along with it to the top, which can be skimmed off and the ore can be recovered, whereas heavier ore gangue particle will be settled at the bottom. Next method is leaching method, which is a chemical separation method. It is a process in which ore is treated with a suitable solvent which dissolves the ore but not the impurities. Purification of bauxite ore to get pure alumina by leaching, which is also called as Bayer's process. There are three steps involved in Bayer's process. First step is the conversion of alumina to tetrahydroxoaluminate. Al2O3 is treated with 45% caustic soda solution so that sodium tetrahydroxoaluminate is formed, whereas alumina is coming into aqueous phase. Second step is conversion of aluminate to hydrated alumina by passing carbon dioxide through the aqueous solution of sodium tetrahydroxoaluminate. Along with hydrated alumina, sodium bicarbonate also will be formed. Hydrated alumina is recovered and it is heated at a temperature 1470 Kelvin to get pure alumina. Al2O3 XH2O gives Al2O3 plus XH2O. Another example for leaching method is the leaching of gold and silver ores. In this method, the ore is treated with a dilute solution of sodium cyanide or potassium cyanide so that gold will come to the solution as potassium dicyanoaurate. And from the solution, the ore, gold is extracted by treating with zinc. So zinc substitute gold and gold will be regenerated. 4Au plus 8KCN plus 2H2O plus O2 gives 4KAuCN twice plus 4KOH. 2KAuCN twice plus zinc gives K2ZnCN 4 times plus 2Au. Similar is the leaching method of silver. Silver also is treated with a dilute solution of sodium cyanide so that sodium dicyanoargentate is formed. From sodium dicyanoargentate, silver is recovered by treating with zinc. These are the different methods of ore concentration. Thank you.